I'm Prashanth. Welcome to day 5 of Prashanth Builds. In day 4, we looked at electronic lab reporting and how lab results enter public health. Today, I want to focus on what happens next. How do we know whether the incoming results belong to a person who's already in the system? This is identity matching and deduplication. A single person may appear in incoming data as John A. Smith or Jonathan Smith or simply J. Smith. Their address may have changed, a field may be missing, but different sources may format information differently. The job of the identity layer is to decide whether these are separate people or different representation of the same person. Identity matching sounds simple until you look at real public health data. The same person can appear differently across data sources. The names can be abbreviated, fields can be missing, addresses and phone numbers can change. The surveillance system receives data from many different organizations. At the same time, we have to avoid opposite problem as well. For example, accidentally merging two different people because they happen to share the same name or date of birth. So this is why a good identity solution or deduplication solution is not about matching everything aggressively, but it's about making high confidence matches automatically, recognizing uncertainty and routing ambiguous cases for review. There are two broad approaches to matching. The first is deterministic matching. This uses exact rules. For example, if a trusted patient identifier matches exactly, or if several strong fields match exactly, the system may have enough confidence to link the records. The advantage is that deterministic rules are straightforward to explain. The limitation is that they can miss real matches when data is formatted differently. The second approach is probabilistic matching. Instead of requiring every field to match exactly, the system evaluates several signals and produces a confidence score. A name might be very similar, the date of birth may match exactly, and the address may be close enough to strengthen the match. For a modern surveillance platform, I would not choose one or the other. I would combine deterministic rules and probabilistic scoring and a human review for uncertain cases. I would design identity matching as a distinct workflow rather than hiding it inside case management logic. First, normalize incoming demographic information, standardize things like names, dates, telephone numbers, and addresses so that we can compare equivalent values. Second, perform candidate search. Instead of comparing incoming records against millions of people, identify a small set of plausible candidates. Third, score these candidates using multiple identity signals. Then make an explicit decision. A very high confidence match might be linked automatically. A medium confidence match should go to a human review. If no plausible person exists, then we create a new person. And every decision should be auditable, so we should be able to explain why those two records were linked and which fields contributed to that decision. Once the system decides the two records belong to the same person, deduplication introduces another set of responsibilities. We need to explain confidence so users can understand the basis of a match. We need human review for uncertain decisions. Every merge and unmerge should be auditable. Most importantly, mistakes need to be reversible. If two people are accidentally merged, the platform should be able to unmerge them without losing the original source history. We also need survivorship rules, meaning rules that determine which demographic values becomes the preferred value when multiple sources disagree. But I would never silently destroy the source values. The platform should preserve what every source originally sent. This brings us back to something that we discussed in day 3, person-centric versus case-centric design. A modern surveillance platform needs both. Identity resolution gives us continuity at a person level, it also separates labs, cases, investigation to be connected to the same individual over time. But each case still needs its own context, workflow, status, and outcome. The person is not the case, and case is not a person. So the architecture should preserve both views, a trusted longitudinal identity and independent case or investigation. Uh, for the next day, we'll take the next step. Once the lab results have been normalized and matched to the right person, how does the system determine whether to create a new case, update an existing case, or send the results for review? And this is where reportability rules or case creation comes into play. So this is day 5. Thank you.